So basically what you need to do is follow along this video quickly, 5-6 minutes probably, and just write down what I write down because you're listening as you're writing, and we'll get through this. So number one, we're talking about dilating a line on this whole sheet, dilating a line from the equation of a line. So when you dilate a line, you multiply the y-intercept, but you never change the slope. So the first problem with this one is that it's not in y-intercept form. So we have to get it into y-intercept form, slope-intercept form, by rearranging the way it is. So I have negative y equals negative 3x plus 4. And then because you don't want to ever start with a negative y, you can just change all of the signs, which is like multiplying through by negative 1. So I haven't done anything yet other than rearrange the line. Then it said by a scale factor of 2. So you multiply that by 2, not that. You leave the slope alone, it stays 3x, and you double the y-intercept. So it's negative 8 instead of negative 4. So make sure it's in y equals form, and then just multiply the y-intercept. Number 2, if a triangle is dilated by a scale factor of 3, what would be true? Well, consider this. If a prime, b prime, c prime is already 3 times bigger, because that's the image, it's already been enlarged by triple, so we have to triple something from the smaller one. So you don't want to triple something that's already bigger, because now it's 9 times as big. So that's not it. This one is tripling the original to catch up with the bigger one. So that's your answer right there. You never triple angles. You never change the size of angles. Angles remain the same. But you triple the smaller one to get to the bigger one. Then you have an equality. Number 3. Again, not in the right form. And the slope has to be the same. But we have to figure out by dividing through by 3 what the real line is. So it's negative 2/3 x plus 8/3. The 8/3 really doesn't matter. We're looking for something that could be the image. Well, anything with the same slope could be the image. So which one of these equations has a slope of negative 2/3? I'll check each one of them, but something cool happens here. I'm going to check A to see if it has the same slope. I'm going to subtract 2x from both sides. And then I'm going to divide through by 3. And I do have the same slope. So negative 2/3. So lucky for us, it was the first choice. The same slope is the same line. In number 4, it gives you the equation of a line in y equals form, so that's good. And it's being dilated by 2, but the center of dilation is strange. It's 4/11. But usually when they give this question, you have to consider something. If the point of dilation is on the line, so if 4/11, let's say that this was the line, and the center of dilation was on the line, then the new line is the same line. It doesn't move if the center of dilation is on the line. So I wanted to see if that was true. If you plug in 11 for y and 4 for x, you get 12 minus 1, which is 11 equals 11. So that point is on the line, meaning if the point is on the line never changes. So if it was 3x minus 1, it stays 3x minus 1. Number 5. A line that passes through 1, 1, and 5, 7. I just sketched it out. If you wanted to use graph paper, you could. I know it doesn't go through the origin, because if it was 1, 1, then it would be 7, 7. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. And it's not. It's, 5, 7? So it doesn't go through the origin. It wouldn't go right through the middle. So I know that it doesn't go through the origin. If I multiply by a scale factor of 3 centered at the origin, then it can't be the original line like the last problem, because that point isn't on the line, so it's going to move. It's going to move down here somewhere, right? So what's going to happen is it's going to move the same distance away again and be parallel. You'll always get a parallel line, because that's what happens when you dilate. You get a line with the exact same slope. Dilating a line always makes a parallel line. Number 6, I already kind of set it up here. I'm going to show you what I did. The line I have drawn there is x minus 3, y equals x minus 3, which is 1x minus 3. So y-intercept of negative 3 with a slope of 1 all the way up. If you dilate from 0, 2, if that's your center of dilation right there, what's the equation of the new line? Well, I made lines of dilation, so I'm going to go from here through a point. It's just easy to go straight down, and it's easy to go straight across. How far is it from here to here? That's 5. So if I go 5 more, I end up right here at 8. If I go 5 that way, I end up right there. If I connect those two, try that again. There we go. You know it's going to be parallel because whenever we dilate, it's parallel. So we know the slope is going to be the same, still just x, 1x, but now the y-intercept is negative 8. So whatever this distance was, I just did it again. So make sure your notes look just like this when you come in tomorrow. If you listened and you wrote this down, then you benefited from it.